Now let us have a look on different types of neural networks. We are going to give it in a very gist form because all of them we have got in detail as different chapters in your upcoming portion or syllabus. Okay, so we are going to see in a gist what are the various types of neural network. The very first and the simplest being feed-forward neural network, which we already saw till now. So feed-forward network is very simple, your multi-layer perceptron model. It's the simplest form of neural network. It is going to consist of input layer, one or more hidden layers, and then an output layer. And definitely it is going to use for simpler tasks like classification and regression. So if I really want to talk on feed forward, I already explained you everything regarding feed forward network, how it is built. So that's it about feed forward neural network. The very second type of popular neural network is convolutional neural network, very popular when you are working with image data. CNN specifically designed for processing grids like data, like images. So you have grid of pixels in an image, so you will use convolution operation, mathematical operation to extract the features of that image and then process with it. That's a different type of mechanism of neural network which we have in syllabus. We are going to see that. So it employs convolutional layers to automatically learn spatial hierarchies of features, means it is going to extract from low level features to high level features layer by layer inside a particular image. Slowly you are going to extract all the features of an image, process that information and give you an output. That will be done in a CNN. It is widely used in image classification, object detection and segmentation of an image. Next is recurrent neural network or RNN. So this we will use it when you are working with a sequential data, like when you are working with text, when you are working with speeches, when you are working with a huge corpus, when you are going to go for caption generation. All of these places you are going to go for RNN. So designed for sequential data and time series analysis. So wherever your data is dependent on time, in those category you will be using RNNs. So it contains recurrent layer that maintains hidden states to capture temporal dependencies. That means it has got a separate strategy to deal with the data which is dependent on time. Okay. It is suitable for the task like NLP, natural language processing, speech recognition and time series prediction. So all these places you will be using RNN. Again RNN is in detail in our syllabus and we will be seeing that. The next two categories that I am dealing with, they are an extension of RNN. Basic RNN model has got some discrepancies or disadvantages. To overcome that, we have got two different designs which are obtained out of traditional RNN model. We call them as LSTM and GRU. Let us see them. So LSTM is long short term memory. So it is a type of RNN model which has got improved ability to capture long term dependencies. That means basic RNN model cannot have a good amount of memory. It cannot work with huge corpus. It cannot work with too many lines of text. It has a tendency to forget. So for that reason, we go for an enhanced memory sequences with respect to LSTM. It utilizes memory cells and gates to control the flow of information. It is excellent for sequential tasks where you have a context over long sequences is essential. When you have got a very small amount of context, then you can go for basic RNN model. If you are dealing with a large amount of sequential data, then better go for LSTM or GRU. Next is GRU. Gated recurrent unit. It is similar to LSTM, but it has got a very simpler architecture when compared to LSTM. It uses gating mechanism to control the information flow and it offers a balance between performance and complexity when compared to LSTM. LSTM gives good performance, but it is more complex. GRU is little less complex when compared to LSTM. Next is a different category which is autoencoder. So CNN, RNN, these are all supervised learning architecture. Unsupervised learning neural network architecture is autoencoder, and this is useful for dimensionality reduction and feature learning, and it comprises of an encoder which is used to reduce input data dimension and then a decoder to reconstruct back that original data. And where do you find these? You will find these applied in image denoising, in anomaly detection, and in also recommendation systems. We also have a chapter based, complete one chapter based on autoencoders and variational autoencoders. So, we are going to see it in that. Next is variational autoencoder, which is an extension of autoencoder, but what is the extension like? It has got probabilistic approach in VAE, variational autoencoder. So, an extension of autoencoder with probabilistic properties is VAE. It encourages the model to generate the data points similar to those in the training data set. So, basically VAE is useful in generating new data samples and data representation learning. Then you have got GAN. GAN is generative adversarial network. It is comprising of two parts, generator and a discriminator network. It trains a particular model, it trains by having the generator and discriminator compete against each other, used for generating synthetic data, image to image translation and style transfer. If you are not able to understand right now in a gist, it's not to worry, we have got a separate chapter dealing with it. Again, an interesting topic is GAN. So, this was about some basic neural network models that you have got in the syllabus, and I have given you a gist of it. We are going to see all of them in detail in upcoming our syllabus.